Yeah. Okay, today we will talk about React Native and how we bridge React Native between itself and the physical world. A little bit about myself. My name is Vladimir Novick. I'm an independent consultant, software architect, author. I usually work on lots of projects in web, mobile, especially React Native, Internet of Things, and virtual reality and augmented reality fields. Lots of stuff. I'm also an author of a book, React Native Building Mobile Apps with JavaScript. It's available on Amazon, it's available on Pug. This is my website. I have a bunch of social links there to my LinkedIn, Facebook. There are also linked to my book, so if you're interested, you can just find it there. And as I said, we will talk about React Native and how to connect to physical world devices. Not especially like this, but at our point in time, how we can connect to like light bulbs, smart homes, this kind of stuff. So let's pause for a second and think how our future will look like. We all want it to look like this, right? In a like very fast, very long time in the future, it will probably look like this. Right now, we know that everything is getting connected, so we already on our way to a better future, probably. So we have our phones connected, obviously we have homes connected, like lots of stuff. Have even smart cities. Actually, I worked on a project, I think it was in Brazil, in Brazil. There is a city, they connect all city infrastructure to, they build kind of smart home for the whole city ecosystem. Have connected cars, we have lots of stuff. Sometimes it goes to really ridiculous things being connected, like this one. We have connected toilets, which is, I don't know, maybe not so good. We have even connected brushes. We can brush our teeth, and then we have watched statistics how well we brushed our teeth. So at some point we'll probably end up here. If you cannot see it, we have to go out for a dinner. The refrigerator isn't speaking to a stove. Yeah, it can happen if the whole home is connected to internet and Wi-Fi is out, nothing working, so you have to go out to get some lunch. And maybe the future looks not as I presented in one of the first slides. Maybe it will be like this. But we don't know. So right now we know that Internet of Things, the term Internet of Things, is in mostly in these fields. So we have smart grid, smart energy. We have agriculture, Internet of Things in general. We have smart retail, like smart mirrors of sorts. We have smart shopping carts. In US, we have Amazon cart store. When you walk in, you just take things out of the store, out of the shelf. You just get out. You don't pay. The mobile app knows what you took and automatically get charged for things. Have smart health, smart mobility, smart homes in general, and open data for lots of stuff. So, in general, how we deal with it as React Native developers. All devices are connected to the cloud, right? So, what does it mean? It means like the regular use of regular things for networking, right? Have GraphQL, have async await, we have fetch. Fetch is used in React Native, it's polyfilled in React Native using the native requests from Android on the iOS side. As well as async await, we can use GraphQL, which is kind of a new one. Have you heard about GraphQL?
Yeah.
Cool. So that's the usual thing, nothing new here, right? So why this talk? About what is this talk? I won't teach you how to connect to the cloud. You already know that, right? But probably you, I don't know, maybe it's my assumption, probably you haven't dealt with Bluetooth, or if you have dealt with Bluetooth, I will gladly share a couple of words how and we'll speak how you dealt with something in your app. But in general, this talk is about Bluetooth in general, and more specifically about beacons technology and BLE, which is Bluetooth Low Energy. It's also called Bluetooth Smart. What is a beacon? This is a beacon. This is a beacon. You say it's a small device, right? It can get even smaller. It's a radio transmitter that transmits an interval of 1/10 of a second, and it can be two formats. Basically, there are several formats, but most formats that I use are Eddystone or iBeacon. iBeacon stands for like iPhone, Apple technology, this kind of stuff, and Eddystone is by Google. It's protocol. I will talk about it in a bit. So, what is BLE in general? We have Bluetooth 5 already out. In our devices, we have Bluetooth 4. Even in low-end Android phones, we have Bluetooth 4. And most of things that we know of right now, working like fitness trackers, smartwatches, this kind of stuff, even several types of headphones work with Bluetooth Low Energy. The main feature of Bluetooth Low Energy is low power consumption. It can run a year on CR2 or 32. It's not a Terminator type, it's just a small battery we put inside the watch. Can show you. It looks like this. It's fine. Yeah. So it's this kind of battery. It's small one. Cool. Now I have two microphones. Yeah. So it's a. Okay. Cool. Nice. First time I experienced two microphones. Great. So okay. It's low bandwidth, 5 kilobytes a second. It has a low latency of 6 milliseconds, and it is discoverable by Bluetooth-enabled devices, meaning by most of the devices we know of. Most of the devices have Bluetooth, so phones are one example of such devices. So before we dive in deep inside how Bluetooth Low Energy works and what is that, and in terms of the protocol and how you use it, let's just go through the terminology. Peripheral is a small low power device. It's like the beacon is peripheral. Central is more powerful device. It's, for example, my phone. It's called a central. And then beacon, there are two basically main terms. There is JAP and JATT. JAP stands for generic access profile, and JATT stands for generic attribute profile. We'll talk about each one of them in a bit. So, what is JAP? JAP makes your peripheral visible and determines how devices are connected. So if you scan for devices and you see this device is available, it's JAP. You're not connected to the device, you just see how, that it's there, it's available, it's in the range, right? So in terms of packets, how it works, we have advertisement data packet that is transferred every couple of milliseconds. And if you want to if your device wants to discover the enabled device which transmits JAP, it's we send to this device a scan response request, and we get scan response results. In this result, we see much more data. So this is how JAP works. So beacons, they don't use JATT. They use only JAP for broadcasting. So what basically beacon does, it just broadcasts, hey, I'm here. So JAP, broadcasting packet data, right? So it's 31 byte custom data to higher lists. Depending on format, data can vary. It can be several things. For Eddystone, it's one format. For iBeacon, it's another format. So we'll talk about Eddystone. Eddystone can be used in for several things. One thing that varies iBeacon from Eddystone, and really great for Eddystone format, is the ability of Eddystone to send custom URI. Meaning, you just take this device, you program it with sending custom URL, and you just broadcast it out there. Several years ago, it was like security-wise, it wasn't really great, because if you have a beacon, every Android device could pick up this beacon and you can get a bunch of URI. It's like watching ads without ad blocker, getting ads all the time based on physical locations. Right now, it's more limited, and basically there are several APIs that allows us to watch this URI. So, as I said, we can broadcast URL, and anyone with physical web, this is standard by Google, compatible with the service will see this URL. So, for iPhone it's one way, for Android it's another way. It looks like this. On Android, if you have nearby API enabled, which can be enabled through settings, or if you have nearby app installed on your phone, you will see this URL is, by the way, the title of my book. You will see it's like an end inside the top. So you will see the URL broadcast to Android in one way. For iOS, it can be broadcasted by installing a specific widget for iOS. And this is one way to use it. So Eddystone, in addition to URI, sends additional data. It has UID, which is unique identifier, has TLM, status data, and EID, time varying ephemeral identifier. What does mean EID? I'm familiar with the RSA security keys that change the key every time. Since one of those, we've seen it? No one? Okay. So it's a like encrypted key that changes every couple of minutes, seconds, whatever. So imagine on this beacon there is a key that changes every time. So with Eddystone, we can use Google Proximity API to get this data and connect the bunch of identifiers and bunch of custom data to the physical location of the beacon. We can say this is a mall, here's a beacon, near the store named ABC. So when somebody enters the store, broadcast this URL. So you get location-based ads, right? And so in terms of architecture, it works like this. You have a beacon. You have a beacon tools app, which is you can install on iOS and on Android. You can program your beacon with whatever data you want, small amount of data, and then you connect it to the Google Proximity API using your Google account. And basically, this ID connects to a whole lot of custom data you can store in the cloud. So even though it's 31-byte packet, right? It has custom ID, it connects to the cloud, so on the cloud you can define for this beacon like any amount of data, whatever you want. So this is how Google Proximity API works and how Eddystone works. For iBeacons, the case is a little bit different. We have iBeacon data is divided by using iBeacon prefix, unique identifier, major and minor, which is small numbers. They also used as identifiers, power of 1 byte, and various flags. So in general, you use the combination of UID, minor and major, to define what, to also connect it to the cloud, more manually though. But you can define that this specific beacon will have this data. We will see in a bit an example how we use it. So you may say, okay, white school, so we have beacon, it's just a proximity tool, but it adds another proximity-based layer of interaction with app users. You know where the people are. You know this to specific location. It's much more precise than geolocation. So Are beacon proximity tools? No, not only proximity tools. By letting know that your device, if your device is aware of physical context, you can define user experience based on this physical context. You know this, for example, user walks in the museum near the specific exhibition, he's there, you can send him things. So it's used for lots of things. It's used for indoor navigation, which is topic of its own, and it's really cool. It's like taking beacons, deploying it inside, for example, in the airport, having beacons like beacon grid inside the airport and triangulating where the person are, and based on his exact location, navigating him to through the airport. We have proximity marketing, automatic check-ins, contactless payments, lots of things. For example, like an example here, you get an ad on your phone. You have a specific application on your phone which talks to the beacons. When you get to the specific area in the store, you get notification for a sale or whatever they want you to be aware of. In museums, there are already lots of museums in Europe that use this feature. When you download Museum app and you go to the specific exhibition, you get an audio guide for this app. Navigation, as I told you, inside the airports or malls like this, when you don't know where to go, the map doesn't help. This is really crucial. So how it works: beacon transmits to device gets the data from the cloud, the custom data, and displays whatever we want. So the general guidelines for physical context-aware apps is enabling location services. It's really crucial. You need to know where the person are. You start scanning for beacons. You check the closest beacon against a server, and then you execute custom logic based on closest beacon. And let's see in action how it works. Let me just show my device really quick. Yeah, so let's just open an app, a bunch of notifications on Twitter, which is fine. And this is the actual app. So I have two beacons here, right? So they will turn red right now, both of them, because they are more than 2 meters away. This probably is almost out of battery. No, it just takes more time. So both of them red, right? So let me put this here. Now it's green, right? Because it's closed. Now it's somewhere in the middle. I need to catch the spot. Maybe here. Somewhere it's yellow. Okay, trust me, somewhere in the middle it's yellow. It's really, here, it was yellow, yeah. And now they will turn green because time passed. So as you see, it's correct to precision of 1 meter plus minus, right? So you cannot, no, my phone locked. So you cannot determine the exact location of the person to centimeters, but meter is much more than geolocation. It's more than enough for the store for anything, right? So yeah. So here in this presentation, there is like a video of this app. So if you want to watch this later, you can see that. So how we actually start actual coding? We use a library called React Native Beacons Manager, and we do the following. We import these beacons from React Native Beacons Manager. I want, in addition to beacons, I want the exact location, right? So I define a region or array of regions. In a real full-blown app, you will have this stuff stored in the cloud, right? So you get the list of regions. Later on, we'll filter through regions and match the beacons to the actual regions. So we have beacons registry. This will also be sit in the cloud. Right now it's just a const. So we have UIDs here, index, major, minor, and name and image URL. This major and minor and UID we will get from the beacon itself. But this data is additional data we want to present in our app, so we will get this from the cloud later on. I said like geo accuracy because when you get latitude and longitude, it's not. I think it's around 8 points after the dot. So and it's fluctuating. So we need to like. If we want set a region to be a size, for example, of this place, it's around 4 points after the dot. So that's something around that. So we have a merge with the registry data function where we just filter the beacons we have and check UIDs, major and minor. So how we start getting data from the beacons? We use request when in an authorization method. We can also use request always authorization method. When in use authorization means when your app is open. Always means when your app is in background. So usually you use request when in use authorization because you don't want like to always request for the data when you're up in the background. Unless if you want the app to do that, you can. Just need to enable, in addition to that, enable background services. So we just get geolocation, latitude, longitude, filter that, nothing specific here. Then we use start ranging beacons in the region. We pass an identifier and UIDs. So let's get back to region map and see what is that. I have UID, right? So by setting the same UID for two beacons, we say these two beacons are in the same region, but they differ by major and minor. So we can differentiate from location A to location B in terms of regions, even though the location can be in the same geographical location. In terms of, for example, we can say these beacons are in this hole, other beacons in the next hole, right? So we differ the regions by UIDs. And the beacons themselves by major and minor. Let's get back to our function. Then we add listener, have device event meter provided by React Native. We add listener to beacons did range, meaning you receive the data from the beacon and then your update state. So this can be done. We can also use instead of beacons did range and start ranging beacons, we can start monitoring regions. It's a little bit different. It's more performant, but it requires the user to actively use the app. So if you want the user to actively use the app and then like provide some notification or whatever based on beacons data, you can use start monitoring for regions and beacons did monitor. If you want just like background things, this kind of stuff, you can use beacons did range. So we get proximity coloring, I have red, yellow, and green as you've seen, and we just map through the registry data, sort it, and just render our cards that you've seen in that. So that was the beacons, right? But BLE is much more. It's not only these small devices, right? It's connecting to phones, to smartphones. We talk at the beginning of the talk about various things, right? So how we do that with Bluetooth Low Energy, and not specifically with beacons. Remember JTT, the terminology slide? I told you that we have JAP and JTT. So JTT is generic attribute profile, part of BLE. And for Bluetooth, we store so-called services and characteristics. It's in a table uses 16-bit ID. The topology looks really similar to JP, but notice the difference. We have peripheral device and we have two-way arrows, right? So our device, looking at JP profile, it getting the packet data, it knows here the device, and then you can connect to actual device. And then you can do stuff on the device, right? So connecting to actual device and manipulating data on the device, like writing to it, reading from it, it's done by using services and characteristics. So services are used for grouping functionality and expose characteristics. You can treat them as services as like utility models, and characteristics like actual variables you write, read, and also can subscribe to. So the characteristic expose data to read, write, and observe. Looks like this. You have Bluetooth, you have a bunch of services, lots of characteristics. You can read, write, get notifications, subscribe to some characteristics, and stuff like that. And yeah, again, demo. Let me just what's the record? Yeah, okay. Yeah, jumping in. Get cut first. Okay, so I built this app will be also available in the same repo as the presentation written in React too, so you can just later on browse and look at the code. So this app is basically does the following. When I click on the Bluetooth button, oh, this stuff is slow. Yeah, you see a bunch of devices here. So you probably have watches here and a bunch of phones, right? So here I will hack your phones. No, I'm just kidding. So say I have, for example, an XY here, which is this beacon, and I have another one, which is this one is called Arc.js. Actually, it's running JavaScript. It's a small operation system called Esperino. It's a small operation system that enables you to run JavaScript on these tiny devices. Cool thing. So, if I click, for example, I have, let me show you. Here, so I have a light bulb here, right? So if I click on it, I have, oh, this is slow. I already clicked like ages ago, yeah. So we have IDs, connectable, local name, bunch of data, right? And we have a bunch of service unique identifiers here. Resolution is not so good, but probably you can see, right? So I can connect to it and click on Discover Services, and I see a bunch of data for the services. If I click on the service, I can discover something on characteristic. This specific characteristic doesn't have anything, but the other one just works. Also, right here, I'm just waiting for this to. Yeah, if I click on Discover Characteristic, I see additional data. Is notified, service ID is readable, is notifiable. So this specific characteristic, or you may call it variable, can be read, can be notified, but you can write with a response to it. Right? So, for example, you can write data to some specific characteristic on the device, but you can't read what's it. You can't get the response. Probably there is another characteristic. You can get notification if this one changed. So, and let's see it in action. Ta-da! see it. Okay, so I can change color. And everything is available later on GitHub. And right now we will walk through the code. It will be a tough one, promise, but we'll take it slow. So yeah, so we have this light bulb, which is basically a clone of like regular light bulb controller. You can get this light bulb for I think it was $7, something like that, and you can just hack with it and do whatever you like in terms of applications. And yeah, we have a video here how it's working, so later on you can watch it. Okay, so for writing, like scanning data, writing to device, we use a library called React Native BLE. This library uses under hood RX Swift and RX Java. So you can for sure use it with RxJS, or you can, I use it with Async-await. We will see in a minute how it works. And let's take a look at the scanner, the first one. The first thing we'll look at how we read data. Later on we'll look into light bulb, how specifically we change the color and stuff. So, have you ever used Mobix? Somebody of you?
Yeah.
Cool. So, people that don't know use Mobix, don't worry. I will explain like in a couple of words. It's a state management system for state management library for React. The whole idea that you have a store, you can inject your store inside the component and observe values change in the store. When values change, your component automatically updates. You don't have a reducer, you still have actions, but you don't have reducers like in Redux. The whole component just updates itself and it looks like magic. It's not magic. You will see how it works. So this is my main JS file, the main endpoint of application. Sorry. Excuse me for a second, I'll just get a bottle of water. Yeah, sorry for that. So, we have upper registry, root component, provider from Mobix React, and Bluetooth store. Then we register our component and we use one called provider that basically use React context under the hood and inject Mobix store inside the context, so you can use it in every component and inject this store in every component. So I create a new instance of this Bluetooth store. Then I have a file called root component.js. In this file, I inject Bluetooth store here. Inject on observer, it's Mobix API. Inject meaning like putting Bluetooth store on the props. And observer means when the store gets updated, my component gets updated. So then I set up BLE manager. So I call the store function of the store to set up BLE manager. How it looks in the store. I import BLE manager from React Native BLE PLX, and I define two actions. One is set up a manager. Second one is destroy the manager. It's really important. When you create an instance of this manager, then it takes resources. So if your application, if you use a screen that doesn't need this Bluetooth functionality, you need to get rid of the manager, so resources will be available and performance-wise the application will work good. So then you call this, you create a new instance of the manager, and here I have BLE state, which is variable available on the store. Whenever it changes, it gets propagated to the store, and on the store we can monitor the status, on the component we can monitor the status based on manager state. For destroy, we just call the destroy function. Then we subscribe for changes. We call this function on Bluetooth store. How it looks on Bluetooth store. Manager on state change. When state gets changed, we update the list. Also, we need to remove subscription. In the same point in time when we want to destroy our manager, before that we remove subscription. So obviously our component will unmount, right? When we are mounting our screen or our app in general, we'll remove subscription and destroy the manager. Now what we do have in the scanner screen, we have this. We have just a button, touchable opacity button, and we call this .scan function. We call scan devices here. This is for like play animation. Probably haven't saw it because of the connectivity issue. When you click on the button, you have like cool animation around. It's I use Loki library for these animations. So we scan for devices. In the store on the manager, remember manager is BLE manager from React Native BLEs, right? So it's API. We start device scan, and we set error if we have error. So if there is no error, and it just filter just my MacBook Pro, so you won't see it in the list. Because I don't know security measures. Add the device list, and in scanner.js I just display these devices. It's an accordion library. When you see when I click on each one, I have like card with the whole data. So when I click, then I had connect button. When I click on this button, I connect and navigate to the other screen, the services. There I call connect device function. On the manager, it's called device.connect. I pass the actual device. So the API is like this, device.connect. For scanning devices with React Native BLEs, you have to start service discovery before you can discover services. It's a separate function, you have to call that, and only then you can scan for the services. So I start service discovery. Then only then I can get services array. This merely sets the servers observable inside the store. And in the same fashion I can discover characteristics. I call characteristic function and I just set the observable on the store. So that's for the scanner. Probably looks complicated because of like jumping from the store to the component. When you see the code in the library, it's much more, I hope it will be much more clear. Anyway, you can just like open the mission and say, hey man, it doesn't look good. Just like change everything. I will do it. So yeah, so I have only a couple of minutes left, so let me just explain about the light bulb, and then I will think we will have time for questions. Okay, cool. And then we'll have time for questions. Yeah, so reverse engineering this thing. What does it mean? I bought this light bulb. Manufacturer didn't let me know what unique identifier of this light bulb is, what is the value I need to pass to the light bulb, how I get it to work. So you had to reverse engineer these things. So there is a device called, there are a bunch of devices. It looks like this. On the right down corner, it's called BLE Sniffer. There is of Adafruit, there is of Bluetooth 1. It's a low-end sniffers that cost between 20 to 100 bucks. There's high-end for like corporation and stuff like that. They cost around 3K, I think. Yeah, 4K. So I don't have the costly one, I have the cheap one. So you can use it and you can export, you can pair it with the Wireshark. and you basically can filter the whole BLE data pass through. So you can get the packet data like you see here. So you need to, you work with a regular app that's available for this light bulb, and you see what values are passed to each service. Depends on your use case. And then you just figure out how things work. It's a topic for another talk actually. If some of you will be at Chain React Conf this year in Portland, I have a workshop there on how you do these things. I will also post several blog posts how you do that. Probably after the conf I will just explain it a bit more detailed way in my Medium. Code-wise, it looks like this. I have to use buffer, which is for writing base64 values. So we import it. We have specific unique identifier of Flatball. We have service identifier that I figured out by reverse engineer. And we have character that also figured out by reverse engineering. And as you see, it's the same one. So the service and the character are the same one for this. And I connect the device. Remember, it was the same one we used for the scanner. Then when my device is ready, I just render the color picker thing. And I just write characteristic with the response. That's it. That's the whole app, right? So you just need to connect the device and you just write characteristics. And the characteristics looks like 56 prefix, color, and some value here. So you figure this out by reverse engineering, and then you just write characteristic to the device. So it's as simple as that. So the rest is React Native regular components for UI, use React Native elements, for example, and stuff like that. So takeaways from this talk: 2 libraries. We have beacons, React Native Beacons Manager, and for BLE we use React Native BLE PLX. So I suggest to dig into these 2 libraries. React Native Beacons Manager is based on React Native Beacons for Android and React Native iBeacon for iOS, and it kind of merges 2 libraries together. The React Native BLE PLX has huge API. I just show you a tiny bit of it. It has lots of stuff there. You were awesome listeners. Thanks for coming. The slides are available here. rm-bridging-physical-world.search.sh, and repo is available here. If you follow me on Twitter at Vladimir Novick, I will just tweet these same links right now, so you can just photo it. Thanks. That's all, and yeah.
Сейчас вопросы. Можно на русском языке? Вопросы?
Can I speak in English?
Yeah.
Where I can buy this stuff, for example, this iBeacons and another one? It's cheaper or not?
iBeacons, beacon costs around $20, something like that. A light bulb costs $7, like a Chinese cheap light bulb. Beacons are there is like these ones are. It's a commercial device. It's like used for tracking your wallet and this kind of stuff. I think this is $20. This is 35, but it has. It's not only a beacon. I just program it as a beacon. It has like a bunch of sensors on it. It's used for like various stuff. And there is various kits with the beacons that can be even cheaper than that.
Okay, thanks. And another question. It's possible to use with like fitness bracelet or something like that?
Yeah.
Yeah, but it's lamp or iBeacons also possible to use it?
It's a different...
No, it's different, but what your opinion, what's best to use?
What do you mean?
I want to make some kind of fitness bracelet. What I need to use that's with JAP or another type of connection.
Beacons for there is no reason to do beacons for bracelet. It's not the use case for beacons. You just use React Native BLE links to connect to it,
okay.
and then you just pass the data. Characteristics, services.
Okay, got it. Thank you.
Спасибо большое. Еще вопросы?
Вопросов больше нет, я поспрашиваю немножко на русском языке. Я хотел спросить, ну, до React Native там на чем-то другом же писали, на нативном, да, то есть iOS, Android. Да. Вот с React Native это стало лучше, да, вот, разработка, чем на нативном? То есть какие плюсы и минусы?
So the question for pluses and minuses of native development for
native,
yeah. So the major thing that was brought to native development, and it wasn't there. Everyone dreamed about it. It wasn't there. It wasn't web for a while. Code model reloading, live reloading. You change styles, everything reflected automatically without need to recompile and stuff like that. So the whole development thing became blazing fast. In terms of like doing actual native development and still doing React Native, the React Native APIs enables to write libraries and just extend to classes, creating for iOS, for example, creating header file, creating M file, just like extending a couple of classing overridden methods, and that's it. Your native API is inside JavaScript. You can pass things through the bridge. It's really simple to still stay on the native side if you want that, and to write common things we use all day long when writing apps like UI and basic functionality and even more advanced functionality right now. We do it much faster. So in terms of timing, for example, writing a bunch of like one screen while doing pure native development and writing this screen for both Android and both for iOS. I don't know the numbers, but it's like it takes some time. It takes different people. You need iOS developer, you need Java developer, right? Java Android developer. So with React Native, the same person that worked on the web can simply write React Native apps. You still need teams for when you're building a team for React Native, for example, for writing React Native app. You still need people familiar with Android and familiar with iOS. But instead of hiring a bunch of folks familiar with iOS and a bunch of folks familiar with Android, you can just use one person for like tiny bits here, tiny bits there, and the whole API is really simple. So it's really faster. In terms of performance, sometimes there are performance problems, but it's really fast to debug them and find what the problem is, because mostly the problem is round trips through the bridge. If you have a bunch of logic going back and forth through the bridge, then it's bad.
Спасибо. Еще вопрос. Вот эта технология Add Beacons, насколько она кушает энергии мобильного устройства, там же сканирует?
For the phone, for example?
Да, для телефона.
Actually, don't use any energy at all. Why? Because phone is automatically getting these packets. You don't connect to the Bluetooth device. It's automatically getting it because in your phone your Bluetooth is enabled, meaning you're receiving JAP packets data. So you don't. It uses the same energy. It's.
То есть никакой экстра энергии нет?
No extra energy, and the beacon itself is half a year for on-down battery. Something around that. This, for example, was 4.5 months. I don't know why. Maybe it's broken. I don't know. And this one, I think it's already. Yeah, it's half a year.
Is there any possibility to recharge it?
No need to recharge. Just like a regular this type of battery, and it's just running because it's just transmitting 31 byte packet data, and it's really simple. I was actually impressed with this one because in addition to being like a beacon, it also has a bunch of sensors and stuff like that, and it's still running for half a year or so.
Спасибо. Еще у кого-то, может, вопросы есть?
Чи є сенс використовувати декілька антенн? Ти розумієш принцип? Is there any sense to use several beacons?
For example, for navigation.
I mean, in one place, like to get more strict coordinates. Actually, these coordinates, are they relate to, or is the actual geolocation?
No, it's basically how it works. It has it's a radio transmitter. So the whole proximity thing you've seen in the application, it's based on a signal, on the frequency you get to the device, right? So if you have two of these devices on the same place, doesn't matter because the way is the same.
No, I mean, in one, for example, in one house,
Mhm.
in one point, in one corner, and in another corner, to get the better location. Is there any sense to do that?
Not exactly, because it will be kind of the same.
I see. So it's
Unless you have a huge home and you like, but then you can just use geolocation. But for example, putting several beacons in the same place is usually used for navigation. Or for example, you want to know inside your home, you want to know that, I don't know, you want to separate your rooms, for example, and you want to find out where your wallet is, for example. So you can put a beacon on your wallet.
Is there smaller versions of beacons?
Yeah, the whole chip is, I think it's like 1/5 of this size, so it's really small. I'm not sure if commercial beacons are smaller, but I think if you just go it, you'll find it. But for example, the use case of the wallet, you put a beacon in your wallet, you put a beacon in each room, right? So you don't know the exact location, but you know that your beacon is near, in the same proximity and same signal strength as beacon from the room A, from the living room. Then you can notify the user your wallet is in living room, and not just like searching where the wallet is and sending notification.
So is there a possibility to do the reversing to find the phone with the beacon?
No, because the beacon only transmits the packet of data, can't receive.
What's about the GATT?
JTT is used. Remember we talked about central and peripheral?
Yeah.
Because the central can connect, and the central can get services, get characteristics, write and read them. Peripheral cannot. Peripheral
Can we use our phone like a peripheral?
Yeah, for sure.
So that means we can find our phone with another device.
If the device is supposed to be a central.
Yeah.
In that case, yeah, but the beacon itself, it cannot be a central. So.
Вопрос, пожалуйста, и Вадим.
How the beacons used in the stores? You said that you may have some, I don't know, mobile phone or some, and get some stuff in the market. And how we can track that you get this product or another one?
How do they do that in the store?
Yeah, in the one shell, you know.
I don't remember exactly how Amazon did that, but there are a bunch of different things you can do. I think they do image recognition and they just see people grab objects. But
It's not a big beacon.
there are stores that use beacons, but as you see, the preciseness of the location is plus minus meter and a meter or something like that. So if you put shells with the distance from each other for like a meter or something like that, and put the same price of products on the one shelf, same price of the product on the other, you know what the person do.
Thank you.
Спасибо большое за доклад.